We want to talk about bats testing for shell scripts, neat test framework there, and how we use ServerSpec to test our Packer-built Docker images. Also, just talk about our team and a bit more about the data org and the big data suite. Not that I'm, yeah, so. Let's say you're working on a project, you've got a number of bash scripts, and they're getting kind of out of hand. You want to know that you're doing the right thing. Heck, you even want to learn some bash yourself. Before you get to test driving your bash scripts, there's a couple things you can do to get started. Obviously, you know, the way that you probably write bash right now, you run the script yourself, see what works, make sure the outputs are what you want, the side effects in terms of files created, files downloaded are what you want. You can read the man pages. They are very good sources of information, time tested, but they don't necessarily teach you how to write bash well. So one awesome tool that we've started using is shell check. Shell check is essentially a bash linter. It gives you stylistic advice about good bash practices. It catches a whole host of errors that folks would otherwise have in their bash, vulnerabilities to what if a function returns multiple file names instead of one file name, so on and so forth. So we've got an example here of the output. It can run over all of the bash scripts you've got in your directories. It will give you alerts about word splitting, tell you how to evaluate subshell functions, stylistic tips in terms of, you know, ls pipe to grep. There's an easier way to do that. You can use for loop, so on and so forth. Each of these citations that they provide, the SC, shell check, and a for code, have been invaluable for everyone on the project to learn bash better. You Google for shell check, and that code brings up a wiki page on GitHub. Their GitHub wiki has really good explanations about why the linter is failing for each of the things. Explanations, examples of better code, and honestly, like, this is how I learned bash. I learned bash by writing bad bash and actually having a way for someone to tell me there's a better way. So the other thing we do with our bash is we actually decompose it into functions. Once you're writing bash that gets complicated enough, obviously we've got this function construct in bash. You just sort of put the parentheses there, some curly braces. Lets you refactor and name conceptual blocks of code, so that's much more readable. And that itself can sort of help other people reading your code detect errors, detect shortcomings in it. Any questions so far about shell check or sort of decomposition? Yeah.
There's like a ton of back and forth about like opinions about what are the simplest ways to do, or
so
like pretty politically, like everybody.
Cool. So the question is, are there like opinions and disagreements? Is it in flux as to what the best practices are? I'd say that the biggest way in which things are in flux is differences between different bash versions, also different shells and so on. Right now we're running shell check against bash 3.2, which is what ships with Mac OS. Even the new El Capitan is going to be shipping with bash 3.2. There exists a bash 4.0. There exists fish shell, K shell, so on and so forth. So that within what shell check's testing, I think it's very clear the recommendations it's giving as to the risks and how to account for them. But obviously within the shell scripting community, there's a whole lot of debate still. Cool. So bats. What's bats? Bats is a TAP-compliant bash script test framework. So TAP is the test anything protocol. It's a very simple, no frills about it, line-by-line text output way of showing the output of assertions, whether you're running unit tests against C++ code or shell scripts, or people have written TAP compliant testing frameworks for a variety of languages. The thing that it does is that it tests your whole scripts, which is pretty cool. That you can sort of test on the status code output of a shell script. You can assert things about the lines that are passed to standard out. But what we really wanted to do was we wanted to unit test our shell scripts. We're decomposing them into functions. Let's actually run our assertions against particular functions. So we rigged it up for better debugging. Part of the shortcoming of the test anything protocol is that it doesn't give room for error messages or descriptive feedback about why tests failed. So we've sort of extended the framework to give us that space and for some function level unit testing. So we're going to show it off a little bit, sort of demonstrating how having bats in place lets us refactor our bash scripts really confidently.
Yes, I can. Is that good? Good?
So the story that we had was write a shell script to check all the other shell scripts in the repository and make sure that if they are a .bash or a .sh file, that they have the executable set on them, the executable bit set on them. It would be really surprising if you sort of opened up a shell file and it turns out it wasn't executable. So we were working along on this story. It was actually an interview story that we did just yesterday. And we can embiggen the Vim as
Spinning
well.
wheel. Hold, please.
Oh, yeah.
Sorry. Wow. Live coding FTW. Oh, it's actually completely not working.
By the way, big props to the IT team. I know they're working really hard on machine images. That's another thing that we're sort of struggling with among the developers. Down in Palo Alto, there are maybe 30 engineers. A couple of them are using Windows. Some of them use Nano as their text editor. Everyone's sort of in different places. And so it makes it hard to develop tools, be the Toolsmiths, for such a heterogeneous dev machine population. Obviously, because we're developing things that are going to go into concourse, it's really natural to just containerize the test assertions and image builds that we want to make. So that's something where we've been working together with IT, also with Abhi and the Sprout folks, to understand what we can do to kind of level the playing field and make it easier there.
This machine is totally not working. I think I'm just going to try to unplug it and then
Sure.
start it up again. Sorry, guys.
And in the meantime, I can tell you a little bit more about our team structure. So I mentioned we've got 3 pairs. We've got 4 labs pivots working together with 2 folks from the data organization, one of whom, Jesse Zhang, you might know from up in San Francisco. So among those 3 pairs, we almost always have 1 pair working on concourse and driving out a full concourse pipeline for the HAWQ product. We've got some streams of work surrounding source control management systems. Right now, the HAWQ team has 3 different source control management systems, one in Perforce, one in Stash, and one at GitHub. So there's some work to be done around that. And our PM is Michael Schubert. He's in New York, comes out to Palo Alto about half-time, a couple of weeks every month. And other key people, Elizabeth Hendrickson, who used to be a director down on Cloud Foundry, is the VP of engineering for all of data. Really big advocate for agile practices, continuous development, deployment. Right now, a big thing that we're working with is making releases non-events. It's awesome that Cloud Foundry can take this complex piece of software, which is multiple different moving parts, moving units, all the code's continuously in development, and cut a release within 24 hours. So that's something big we're moving towards. Scott Yara. Yeah.
Sorry, didn't mean to interrupt you.
No, you're good.
I have a microphone in my hand now. This must be a very important question. I'm curious why you guys went with Bash. Did you have a choice? And if so, what were the things that led you toward Bash and away from Python or whatever?
Yeah. Couple things. So we are working pretty frequently with machines that don't, machine images that are just barely getting things such as Ruby or Python installed on them. We're taking advantage of Concourse's modularizing and sort of making artifacts first class so that we can step-by-step build up machine images to our specifications so that CI is very consistent and not flaky. So in some sense, Bash is kind of what we've got available. The other thing is that we're working with the file system basically as a first-class object, like the file system and how packages are installed and where files go, how ports are set and networking is set up. That's kind of the meat and potatoes of what we're doing with a lot of our stories. And so it makes sense to stay in Bash world rather than go up into a higher level language, even though those higher level languages do have DSLs and ability to work with the file system. So.
I think we're good.
Okay.
Let's see if it stays that way.
Sweet. So this is what a bash test, a BATS test looks like. You say at test, you write out your assertion. What BATS is doing under the hood is that it's actually reading through this file x+1 times, where x is the number of test cases. It reads it once to sort of identify what test cases it should be running, and then for the remaining ones, for each subsequent run, it considers each of the tests a function that it is calling, which sort of closes up with assertions in the form of, I assert that this particular operation exits with a status code of 1, meaning that, I'm expecting that if there are files that are not executable, but they're bash, I expect that to fail. So we can set up basically a test case. BATS is giving us a temp directory for each test run for free. So we can set up a test case, dummy files, make some of them executable, make some of them not executable, and go from there. If you pull up the code, we had one particularly little bit gnarly find statement, and the request was that Concourse vendors in some files into our temp directory, and some of them are shell files, and some of them are not executable, and they're not our code, and we don't really care if they're executable or not. So what we wanted to do was ignore the temp file.
Where did that live again? I
Yep.
forgot.
Under tasks. And it's the verify executable shell functions. Yep.
Yep. Try to do it slowly but surely this time.
So right up there at line 3, we're starting with finding things for which the name is .bash or .sh throughout our whole directory structure. Already, we've had to go through, jump through some hoops because shell check is very clear about the safest ways to run find, and so inlining it was risky based on its possible output being multiple files or a single file. Also, you might be wondering, well, isn't this like a glob? Can't you just do */*star.bash? And that's not a feature until bash 4.0. So we're working with bash 3.2, don't have globs. We wanted to take this find statement and add in support for ignoring the temp directory. So basically say -not, -path, the temp directory. But before we do that, we wanted to extract that into a method. So if you run if you go back to the terminal and run the bats tests, spec tasks, yep. All of our bats tests pass. We can go back into the code, make a new function, which is, you know, list of executable, or list of scripts, let's say. Yeah. And from there we can take the find statement.
Sorry. Let's do that.
Yep. Yep. Don't since it's within a function, we don't need to evaluate it in a subshell. We're sort of getting the subshell. Yep. And then up in matched files, we can change that to the function call name. And we can move the comment down into the function, or really actually delete it. You know, now that we're extracting this into a separate method, you know, we're specifically saying this is a method that we might want to test. We want to test that it doesn't get things from the temp directory, doesn't get things from the temp directory, does get things from everywhere else that ends in shell or .bash. So. And let's run the bats tests again and see what happens. Okay. And looks like we got a lot of failures. But this is good. This is what we've got the test coverage for. So if you go back to the MVim, we can see, oh man, at list 3, or at line 3, I actually still need to evaluate that inside of a subshell. So let's evaluate list of scripts inside of a subshell. No, actually on line 3.
Oh, sorry.
Yep. Hey, cool. If we wanted to get more output from this, we've got some helper functions that we've more debugging output from this. We've got some helper functions to spit out logs from any given test run and so on and so forth. So, so that's a quick summary of what we can do with bats and how that helps us refactor things. Any questions on bats? Yeah, Laura.
You said that you guys had extended or modified this framework. Do you publish those changes somewhere? Or?
Not quite. No,
We probably should.
yeah, no, it's definitely on our list. So, yeah. When we were evaluating test frameworks for shell scripts, we looked at a couple different options. This one seemed the most vanilla and open to adaptation. And it was not so stale. It hadn't had a commit on GitHub in the past 11 months, which is less than a year, so yeah. But not like in active development. Other questions about bats? Cool. So let's move on to using Packer templates for Docker images and how that leads to us shell checking them.
So for those of you who don't know me, my name's Ben. I'm working down in the Palo Alto office with CJ. So one thing that we came across a lot in our development, when using Concourse, is we are pretty heavily reliant on Docker images. We need them to spin up individual images for different versions of the operating systems that HAWQ is going to be running on, as well as the build images for the specs that we're going to be running, including the shell scripts. So one thing that we found was that reconfiguring all of these different Docker images was not only time-consuming, but pretty tightly coupled to the specification with the way the images run, as well as the specification of the image. So Packer was suggested as an idea to sort of separate these concerns and help make our development easier. So the way that part of the way that Packer works is you actually just give it a JSON sort of manifest file describing where you want to pull something from, as well as a list of maybe a script you want to run once you actually do run Docker run and run the image. So that allows us to kind of separate that a little bit easier. And not only that, once we actually have Packer to actually deploy the image instead of running in Docker, we run a ServerSpec. And ServerSpec is a gem that allows you to test individual things about servers. Right now, most of the tests that we do are relatively basic. We just want to make sure that we have the correct version of what we expect to be running our own CI pipeline on, as well as the pipeline that eventually HAWQ will be up and running on. But the great thing about that is it gives us a structure to eventually add more tests to as the complexities of HAWQ start to unravel themselves once we get it deployed in our pipeline. And CJ is going to show us what our Concourse pipeline looks like now in production to give you an idea of how that's all laid out. So this Concourse job is Ruby Stack image build. This is what happens here is we set up the image for use in all of our spec tests and the rake tests that we run in the latter half of our pipeline. So as you can see, we get a Packer Builder image resource. That's actually our set that we're running Packer on. We start at the very beginning with a job that gets Packer set up and ready to go because we're going to be using it in all the subsequent jobs. From there, we run Packer builds with that JSON file I mentioned that gives all the specifications. It runs through Docker, and once it does all that fun stuff, that really long fun stuff, should be relatively small towards the bottom, I think. Cool. And then we run the ServerSpec, our spec file, just with a basic bundle to keep that, again, separated from all the other stuff we're doing. And then we run a ServerSpec on what the actual version of Ruby that we have installed is to make sure we're using the right one. Again, relatively basic, but it's definitely going to be extended a lot in the future as we run into new scenarios where we need to rely on specific functions of our Ruby. And then once we're done, we push that up, in our case, to our private Docker registry. The following builds will take that image and then run our specs on them. So yeah.
So hey, Ben.
Yes.
This is pretty awesome. And as a team, we've even set up a Concourse instance that runs locally. But that
True.
still takes too long.
It does. So one thing that we actually do to help mitigate that, and so we don't have to continuously commit things and have this just continually run up in Concourse, is we've developed a solution to run Packer build locally, and that will allow us to actually run our server specs locally as well. So we don't have to make changes to our server spec, push them to Concourse, and then wait X amount of minutes to get it all squared away. Cool. So you see here, basically what we're doing is we're just giving it a random temp directory to work with, running Packer builds, and telling it what kind of we're telling it to just give us a tarball of what we want. And then the last portion you see is the manifest file that we give to Packer build to specify all the things that we want. And at the end of that, because we have Docker machine running, we Packer build out all the stuff we need, export it to a tarball, and In the spec itself, we allow you to set an environment variable, setting the tarball you want to use, and we just run RSpec with a spec file, and it will. And ServerSpec has its ServerSpec as well as a Docker API gem allows us to import that tar and then run specs against it, and it works out pretty well.
Yep. So this is as simple as a Packer template comes. We're naming it. We say, in this case, use Docker to build it. Build off an Ubuntu image. We give it where we want the tar file to be put afterwards, and just point it at a bash script that describes how we want it to install Ruby. So with this, it's easy enough for me to kick off, build here. So this will, Docker machine. That's interesting.
So we had started a VM before doing this. That way we didn't have to do that. But apparently it's not.
Yep.
running.
Apparently our Docker machine is down.
Sorry about that.
But we can still run our RSpec right here on. It's a cooking show. We get the image out of the oven right hot, and
It's not there.
it's not there either.
So we had also had the tar already exported, apparently, but now that's also gone.
Okay.
But you can imagine how it works. We sort of showed you. We sort of showed you the output. It does work. Trust us. Yeah.
Yeah. So questions about how we're building up images, why we're building up images like this, so on and so forth.
Cool.
So I was talking a little bit earlier about our team. Also mentioning Scott Yar, he's the president. Obviously came from Greenplum and is still involved in the direction of the product in that side. Duncan Lords, the senior director of product. Overall, the PMs and so on and so forth. There's a pretty significant field organization, so he can gather requests from them or from specific customers. And then just mentioning Addison. Addison took over in Nick's place, working with the HAWQ team a fair bit back throughout the summer, and now he's transferred fully over to the data org. So he's working as the PM of the query optimizer and execution teams. So that's pretty exciting. He brings the same agile principles and so on right there into the data org. So. And quick summary about what we're doing with cloud native data apps. I very explicitly am stealing this from a sales presentation. So we think about Cloud Foundry and what Labs is doing with all of Cloud Foundry. Where does data fit into that? Some cloud-ready things right away would be Spring Cloud data flow, how they're ingesting data, and Pivotal Gemfire, the quick serving layer. And neither of those are necessarily in Palo Alto. I'm not super familiar with them. The things that we're working towards, getting sort of cloud ready and getting better integrated with the Cloud Foundry ecosystem, and the idea that developers don't really have to care about the infrastructure or the services that are running alongside. Our Greenplum database, Pivotal HD, which is our distribution of Hadoop, Pivotal HDB, which is the name of what used to be HAWQ. HAWQ just went open source like 2 weeks ago with Apache. So we're in the process of renaming and rebranding our private offering. And then Madlib, which is a machine learning tool built on top of R to plug in with data that's stored in Hadoop. So a couple different teams working in Palo Alto. HAWQ is a fork off of Greenplum. Greenplum was a fork off of Postgres. So we're talking about a lineage of relational database interfaces, but now going against the power of Hadoop. So. I'm not the expert on this, but I'm glad to take any questions you have about how Pivotal data is working together with the rest of Big P Pivotal and how we work with them. Like I mentioned, we are open sourcing them. It's a little bit of a slow sort of working through it process, especially when we think about what the Toolsmiths team are doing. We're mid-flight getting Concourse up and running for the existing code base, and then with open sourcing, Apache requires us to also have a public-facing CI system. So different things to work on. We'd like to have Concourse be the public-facing sort of CI system of record, but we're still working towards that. So yeah, that's what we've got. If you've got more questions afterwards, feel free to come up and talk. We will try to get you the answers. If you're in Palo Alto, come and visit.